Hello everyone, welcome back to our Python lecture, and today's session we are starting a new and very important unit, Object Oriented Programming, also called OOP. Okay, so Object Oriented Programming is one of the most widely used programming approaches in software development. Many large applications and software systems are designed using object oriented concepts because they helps us organize code in a better way. So in this lecture we will understand what is object oriented programming, why do we need OOP, advantages of OOP, basic concepts of OOP, classes and objects, creating classes in Python, creating objects, constructors, attributes, methods. So let's start with the basic question. What is object-oriented programming? Object-oriented programming is a programming where programs are designed using objects. In traditional programming, we mainly focus on functions and procedures. But in OOP, we focus on objects that contain data and behavior. Data represents the information about an object. Behavior represents what an object can do. For example, consider a real world object, okay, a car. So a car has data, color, model, speed, fuel level. A car also has behavior. Okay, so a car also has behavior. Start, stop, accelerate, brake. In OOP, we try to represent real world entities like cars, students, employees, and bank accounts as object. Okay, so real world understanding of loop. Let's take another example. Okay, a student object can have data like name, roll number, marks, age, and behavior, display details, calculate average, update information. So instead of keeping data and functions separately, OOP combines them together inside an object. This makes program more organized. Okay, so just wait. Okay. So why do we need OOP? Now the question is, why do we need object oriented programming? For small programs, normal programming approaches may work, but when applications become larger, managing thousands of lines of code becomes difficult. Okay, so OOP helps solve these problems. The main reason for using OOP are because it is better organization, code reuse, easier maintenance, real world modeling. Okay, so better organization of large programs. In large software projects, there are many different components. For example, an online shopping application may have customer, product, order, payment. Using OOP, each entity can be represented as a separate class. For example, customer class, product class, order class. This makes the program easier to understand. Okay, so code reuse. Okay, one major advantage of OOP is code reuse. Instead of writing the same code again and again, we create classes and return and reuse them. Okay, for example, a company may have many employees. Instead of writing separate code for every employee, we create one employee class and then we create multiple employee objects. This reduces duplication. Okay, so talking about encapsulation, this is the first major concept of OOP. Encapsulation means combining data and methods together inside a single unit. That unit is usually a class. For example, a bank account class can contain data methods. In data, account number, balance, and methods means deposit, withdraw, check, balance. The data and operations related to account are grouped together. Okay, so now talking about inheritance, it is the second important concept. Okay, so inheritance allows one class to use the properties and methods of another class. It helps in code reuse. For example, animal is a general class and dog is a type of animal. So dog can inherit common properties from animals. We will discuss inheritance in detail later, okay? Okay, so polymorphism, the third concept, okay? So polymorphism means many forms. It allows the same method name to behave differently in different situations. Like for example, a sound method. Okay, dog barks, cat meow. The method name is same but behavior changes. Okay, so that's the reason. Okay. Okay, so let's summarize why oops is useful. Okay, so number one, just wait. Okay, number one is modularity. Okay, programs are divided into smaller independent parts. Each class handle its own responsibility. Number two is reusability. Okay, so existing classes can be reused. This saves development time. Number three is maintainability. Changes become easier because code is organized. Okay, so number one is real world mapping. OOP allow programmers to model real world entities naturally. Okay, so if you want to write these things in your notebook, alright, take your time. Okay, so now let's understand the most important term in OOPS, class and object. Okay, these two concepts form the foundation of OOP. What is a class? A class is a blueprint or template for creating objects. A class defines attributes, methods. Think about a class as a design. Okay, for example, a car design created by engineers is a blueprint. It describes shape, features, structure, okay? But the blueprint itself is not a real car. Similarly, a class is not an actual object, it is only a definition, okay? Okay, so object. What is an object? An object is an actual instance of a car class. Using the car example, like class car design, an object is actual car produced from that design. Each car object can have different values. For example, there is one car, color is red, model is BMW, okay, and the second car color is black and the model is Audi. Both belongs to the same class but have different data. Okay, just wait. Okay, so class versus object, let's compare. In class is a blueprint, defines structure, define behavior, and no real values. Okay, for example, a student. Okay, an object has actual instance, has real values, uses class behavior. Okay, for example, student named Rahul. Okay, so let's move to the next part. If you guys want to write this in a notebook, you guys can do. त्योहार मुबारक हो। आपसे पहले भेजा है मैंने, तो कितना चंट है यार। तेरे को पता है मैं भेजूंगी, मेरे मैसेजेस का रिप्लाई नहीं कर रहा, 111 के लिए रुक रहा है, बताओ। Okay, so now let's see how we create a class in Python. Python uses the keyword class. The basic syntax is, you can see here, class student. Okay, the class name usually follows cap words naming style. Example, for example, like students, where S will be capital. Okay, and bank account, employee, where B will be capital, E will be capital. Okay, simple class example. Suppose we create here class student pass. Here we have created an empty class. The keyword pass means no code is written inside the class. The class exists, but currently it has no attributes or methods. Okay, so now let's move forward. Just wait, okay. When Python executes a class definition, it creates a class object. The class can then be used to create actual objects. So the flow is create class, create objects from class, use object attributes and methods. Okay, so now let's move forward. Now let's create objects from a class. Suppose we have class student pass. We can create S1 is equal to student, S2 is equal to student 2. Okay, so here S1 and S2 are two different objects. Both are created from the same class. Okay, so one more important point. Multiple objects can be created from one class. Okay, for example, student class objects will be student 1, student 2, student 3. All objects use the same class structure, but each object can have different data. Example, student 1 dot name is equal to Rahul, student 2 dot name is equal to Rishika. Okay, so if you guys want to write, you guys can. Okay, so now let's move forward. Now let's learn about constructors. A constructor is a special method that runs automatically when an object is created. In Python, the construction method is init. Okay, here you can see this is the constructor. It is used to initialize object data. Okay, so understanding init, for example, you can see here. Okay, so when we create S is equal to student Rahul, the init method automatically runs. It stores self.name is equal to Rahul. Okay, so constructor real life example. Okay, when a new car is produced, the factory worker automatically sets color, engine, model. Similarly, a constructor sets initial values when an object is created. Okay. Okay, so instance attributes and access. Okay, so attributes are variables that belong to an object. They store object specific information. For example, you can see here, this is the example. Here name and age are attributes. Okay, here you can see name and age are attributes. The self keyword, okay, The keyword self represents the current object. It allows us to access object data inside methods. For example, self.name. Okay, it means the name belonging to this particular object. Okay, after creating an object, S is equal to student Rahul 20, we can access S dot name, output will return as Rahul, and if we just wait, okay, and in here S dot age, output will return us, just wait, okay, so output will be 20 if we print S dot age, okay, and modifying attributes. Okay, attributes can also be changed. For example, here you have seen that s dot age equal to uh, matlab age s age is 20 here, but if we want to modify, for example, s dot age equal to 21, now the age value becomes 21. The value, the object data is updated. Okay. Okay, now we will continue our discussion with two very important concepts, method and inheritance. Methods define the behavior of objects and inheritance help us reuse existing code. So let's begin. So a method in a function is a function that is defined inside a class. In simple words, a function inside a class is called a method. Methods describe what an object can do. For example, a student object can have data like name and marks and behavior like display details and calculate average. The behavior are created using methods. Okay, so just wait. Okay, so difference between function and method, okay? A normal function is created outside a class. Example, just see, wait. Okay, a method is created inside a class. Okay, that is clear. And now self parameter. Okay, in Python, every instance method takes a first parameter called self. The self parameter represents the correct object, current object. It allows the method to access object attributes. For example, class student print self.name. Okay, so here self.name, here self.name means the name attribute of the current object. Okay, so here we are creating methods with attributes. So here you can see, now we create s is equal to, just wait, s is equal to student Asha 88. When we call s dot display, the output will be Asha 88. So how methods work? Okay, let's understand this execution. When we write s dot display, Python internally passes the object student.display. The self parameter receives the object reference. That is why methods can access attributes. Okay, so multiple attributes in objects. An object can contain multiple attributes. For example, an employee object may contain employee ID, name, salary, department. A class allows us to combine all related information together. Okay, so why you use methods? Methods provide several benefits. Number one, organized behavior. Methods keep related operations together. For example, bank account, we have deposit, withdraw, check balance. Okay, and this Second, and the second benefit is code reuse. The same method can be used by multiple objects. Okay, so number three, better program structure. Class contain Classes contain data and methods together, making programs easier to manage. Okay, just wait. So now let's move to another important OOP concept, inheritance. Inheritance allows one class to acquire properties and methods from another class. So the existing class is called parent class or base class. The new class is called child class or derived class. Okay, so real life example of inheritance. Let's understand using a real world example. Consider animal and dog. A dog is an animal, right? The animal class may contain common features. Eat, sleep, move. The dog class can inherit these features. The dog class can also add its own behavior, like bark. So instead of writing common code, we reuse it. Okay, so why do we need inheritance? The main purpose of inheritance is code reuse. Suppose we have many classes with common features. Instead of writing the same code repeatedly, we create a parent class. Child classes can reuse the parent functionality. Okay, so talking about the advantages of inheritance. So inheritance provides number one, reusability. Existing code can be reused. Okay, and number two, less duplication. We avoid writing the same methods multiple times. Number three, better organization. Related classes can be grouped together. Number four, easier maintenance. Changes in parent classes can automatically affect child classes. So write down in your notebook for notes. Okay, so implementing inheritance in Python. Inheritance is created by placing the parent class name inside parentheses. Okay, so simple inheritance class. Suppose we create class animal. Define sound cell. print animal sound. Here you can see the example. Okay, here animal, see, animal is the parent class. Dog is the child class. Dog automatically gets the sound method. Okay, so now D is equal to dog, D dot sound. Output will be animal sound. Although sound is written inside animal, the dog object can use it. This is called inheritance. Okay, so just wait. Okay, so the relationship, just wait. Okay, so the relationship is animal is dog. Dog is a type of animal. This is called is a relationship. Examples: car is a vehicle, teacher is an employee, student is a person. Okay, I think that's clear for everyone. Okay, so types of inheritance. Python supports different types of inheritance. The major types are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance. Let's understand each one. Okay, so talking about single inheritance. Okay, just wait. Okay, so single inheritance means one child class inherits from one parent class. Structure parent, just see here. This is parent and this is child. Okay, just for example. Okay, let's imagine this is animal, this is dog. Only one parent is involved. Okay, this is the simplest type of inheritance. Okay, multiple inheritance means one child class inherits from multiple parent classes. Like here you can see, just imagine parent A, parent B, and this is child. Okay, for example, a child class may inherit features from two different classes. Suppose, okay, so talking about multi-level inheritance, it means inheritance happens in multiple levels. Okay, structure A, I mean class A, class B, class C. Animal, mammal, dog. Dog gets properties from mammal and animals. Okay, so that's clear. Okay, I'll give you one example. The child of one class becomes the parent of another class. This creates a chain. For example, vehicle, car, electric car. So electric car gets feature from both car and vehicle. So that's the example, okay? I hope that's clear for everyone. So talking about hierarchical inheritance, it means one parent class has multiple child classes. Structure, like here you can see A, B and A, C. Okay. So, for example, just wait, okay? Okay. So, just wait. Okay, I'll give you one example. While designing programs, we should just wait. Okay, for choosing the right inheritance, while designing programs, we should choose inheritance carefully. Simple inheritance structures are easier to understand. Too many inheritance levels can make programs difficult to maintain. The goal is create meaningful relationships between classes. Okay, just wait. Okay. Method overriding. The first concept is method overriding. Method overriding happens when a child class provides its own implementation of method that already exists in the parent class. In simple words, the child class changes the behavior of the inherited method. Why do we need method overriding? Inheritance allows a child class to use parent methods, but sometimes the child class needs a different behavior. Instead of creating a completely new method, we can override the existing method. This allows customization. So real life example of overriding: the parent class animal has a method sound. The general implementation may be animal sound, but different animals produce different sounds. Dog bark, cat meow. So the child classes override the sound method. Suppose we have, here you can see the example. Here dog has its own version of sound. When we create dog and call d dot sound, just here, okay, just wait, there is a cursor, okay, d dot sound, the output will be bark, right? So Python checks the object type first. The object is dog, so Python looks for sound inside dog. Since dog has its own method, it executes dog's method. The parent method is not used. This is called method overriding. Wait. Okay, so advantages of method overriding. Method overriding provides number one, flexibility. Different classes can have different implementations. Number two, polymorphism. The same method name can behave differently for different objects. Number three, better design. We can create common interfaces while allowing different behaviors. Okay, so note it down if you guys want to write this in your notebook. Okay, so now let's learn about super. Okay, sometimes we do not want to completely replace the parent method. We want to use the parameter. We want to use the parent functionality and add some extra behavior. We want to use the parent functionality and add some extra behavior. For this purpose, Python provides super. Why use super? Suppose we have a parent class, animal, okay, with name attribute, the child class dog, and dog also needs base attributes. So instead of rewriting the parent initialization code, we use super. Okay, so accessing private data. Okay, so direct access, employ. Okay, so now let's discuss function overloading. Function overloading means having multiple functions with the same name but different parameters. Okay, so in some programming languages like C++ and Java, this is directly supported, but Python handles it differently. Does Python support traditional overloading? Python does not support classical compile time function overloading. If we create multiple functions with the same name, the latest definition replaces the previous one. Instead, Python uses flexible approaches. Okay, so overloading using default parameters. For example, just wait. Okay, here you can see def greet is equal to name is equal to guest. If we call greet, okay, so the output will be hello guest. If we call greet, so the output will be greet. If we call greet Rahul, okay, so the output will be hello Rahul. The same function handles different cases. Okay, so overloading using arguments. It allows a function to accept multiple number of arguments. For example, just see the example. Here now add 2 comma 3, output will be 5, and add 2 3 comma 4, the output will be 9. The function works with different numbers of inputs. Okay, so overloading using this. Okay, quarks. Python also provides quotes. It allows variable number of keyword arguments. Example, like for example, def display quirks. This can accept different named values. Okay, why flexible arguments are useful? This they make functions more adaptable. Instead of creating many versions of the same function, we create one flexible function. Okay, so now let's move forward. Just wait. Okay, so now let's apply these concepts through some practice problems. These problems are based on real world examples because OOP is mainly used to represent real world entities as objects. Problem 1. Create a bank account class deposit, withdraw, balance, handle, overdraft. So you have to create. So first let's understand the real world object. Okay, a bank account is an object. Every bank account has some data and some operations. So here the attribute a bank account can have account holder name, account number, current balance. These are called attributes because they describe the object. For example, if Rahul has a bank account, his account number and balance are the data of the object. Okay, so this you have to do this question by your own. Okay, so do it. So, in the second problem, we have to create an employee class. It contains employee details like ID, name, salary. Okay, the raise percent method increases the salary by a given percentage, and the display method shows employee details. This demonstrates how attributes and methods work together in a class. So, do this question too. So, in the third question, here you have to create a rectangle class with width and height as attributes. The area method calculates the area using width into height. The perimeter method calculates the boundary length. The scale method changes the size of the rectangle by increasing or decreasing its dimensions. Okay, so do it by yourself. Okay, so number four problem. In this problem, we extend the student class. We add a method to calculate average marks. Okay, we also compare two student objects using the eight method. Okay, so just wait. Okay, which allows us to compare student based on their marks. Okay, you have to do this questions too. So this completes our Unit 5 on object-oriented programming in Python. The main idea of OOP is represent real-world entities as objects, classes define structure, objects store actual data, methods define action, inheritance provides reuse, encapsulation provides protection, polymorphism provides flexibility. These concepts are the foundation for building large software applications. Keep practicing these concepts with small programs, and gradually you will be able to design complete applications using Python. Oops. Thank you.